Welcome to LJ Institute of Engineering and Technology in the Department of Instrumentation and Control Engineering. In this session, we are going to learn about the subject that is Industrial Drives and Control. I am your instructor, Jayesh Prajapati. Actually, in our last online section, we have already discussed the unit number 1, unit number 2 and unit number 3. Now in this session we will discuss the unit number 4, that is chopper control DC motor drives. A chopper control DC motor drives is chopper control drives. That means to convert fixed DC voltage into a variable DC voltage, that is done by the chopper. So actually we have discussed the unit number 3, that is DC control drives. Now in this session we will discuss the chopper control DC motor drives. In this chapter number 4, we have discussed the content, that is first content, that is a principle of operation of chopper. So in this first topic we will discuss the basic principle of chopper circuit and how it can be worked, how it converts fixed DC voltage into a variable DC voltage. Then the second topic, that is a most IMP topic, that is a 4-quadrant chopper circuit. In the 4-quadrant chopper circuit we have studied a first quadrant, second quadrant and fourth quadrant chopper circuit. Now the next topic, that is a chopper for inversion. Then input to the chopper circuit and other chopper circuit that we have to discuss in this next topic. And the last topic, that is a closed loop operation. So that is a theory content that we have to study in this chapter number 4. So let us start with this content first. Now the question is, what is chopper? Okay, first of all we will discuss the basic definitions of chopper. So you can see the question is, what is chopper? The answer for the question, that is, a chopper is a converter that convert fixed DC signal into a variable DC signal. Okay, so basically a chopper, that means nothing. It convert a fixed DC voltage into a variable DC voltage. Okay, you can see in the figure, chopper has an input, that is a fixed DC input. It convert fixed DC at the output like variable DC voltage. Okay, you can see a fixed DC signal, okay, a constant DC signal, and at the output there is a variable DC signal. So that is a main concept of chopper circuit, to convert fixed voltage into a variable DC voltage. Now that are the some drive circuit figures. Okay, different series of DC controlled drives. Now the principle of operation of chopper, that is our first topic. So let us start. A chopper is basically a switch which convert and which connect and disconnect the load across the DC input supply. So chopper basically work like a switch. It connect and disconnect DC input supply. So let us see this by some figures. So you can see in the figure, first we have take a DC supply. Then from this DC supply we have to connect across this load. Okay, then we can use one switch. So here we have connect DC supply across the load by using some switch which connect and disconnect the load as per our switching operation. So here that is the output voltage V0 plus minus polarities. Then this is a control voltage VC. And here this switch, you can see here in this switch, that is our chopper circuit. We can say that this switching circuit, that is our chopper circuit. Now input, that is a fixed DC voltage, because we can connect batteries, okay, across the input, that is a VS source voltage, okay, that is a fixed DC input. Then the output will be a variable DC output, okay, across the load, whatever the output V0, that is a variable DC output. So now we have see this explanation in the waveform. Then it's look like this. You can see in this waveform we have take some axis, y axis, and then some x axis for drawing the waveforms, and also we have taken some lining axis. First, that is a time period t, then 2t, and then 3t, that is the time periods. Then the first waveform, that is the output voltage V0, okay. First, that is input voltage Vs. So input voltage, that is a constant, we can say that is a constant waveform. Then the control voltage waveform across this chopper circuit, it's like this switching waveform. You can see here we have provided the switching, so it waveform is like this: on, then off, on, and then off. Okay, switch on, that times the waveform is in higher portion, and when switch is off, that time it will be 0. Now the next waveform, that is the output voltage V0. Control voltage waveform is lower, but the output voltage is, we can say that is a high. So here we have draw as a high. So first the switch is on, then off, then again it will be on, then off, and then on. Okay. So that is a waveform for the chopper circuit. Here in this figure you can see this period is shown by the on time period T on, and this period we can say that is a off time period, that is T off. Okay, so that is the on and off time period for the chopper circuit, and from this on and off time period we can say that it can be work on duty cycle. Okay, a duty cycle, that means it is the ratio of on time period divided by the total time periods. So if we see the equations for duty cycle, then in this figure you can see D is equal to T on divided by T is equal to T on into 1 by T, that means frequency F, and we can say that it is also like T on divided by total time period, T on plus T off. So in this equation we can say that D, that is equal to a duty cycle, and F, that is equal to the chopping frequency. So that is the principle of operation of chopper circuit. So here we have only discussed the basics of the chopper circuit. Now we have go to the next topic, that is chopper 4-quadrant chopper circuit. In this 4-quadrant chopper circuit we have to draw the basic circuits. So a 4-quadrant chopper circuit with a transistor switch is as shown in the figure. So let us see the figures for a 4-quadrant chopper circuit. So first we have take input voltage, fixed DC input voltage Vs. Okay, then we have draws some circuits. Then we have take the capacitor CF for constant DC voltage supplied to the 4-quadrant chopper circuit. Then we have take first transistor T1, then transistor T2, then transistor T3, and then transistor T4. Okay, across the transistor we have connect the feedback diodes D1, D2, D3, and D4. So that is a basic circuit. Now we have connect this circuit. Okay, you can see we have connect this circuit. Now we have take load circuit. So we have connect at the center portion we have connect load R, A, then LA, and E, that is back EMF. So that is armature circuit. We can say that is RA, LA, and E, that is a motor armature. So we have to connect this circuit across the motor armature. So basically in this figure you can see a 4 transistor and 4 diode circuit is connected across this load. Load means our DC motor. So that is the figure, and that is the output voltage V0 plus minus. So that is a 4-quadrant chopper circuit. Now we have to operate this 4-quadrant chopper circuit in the every 4 quadrants. So we have take here we have take a supply current, and here that is IA, that is a armature current. And for 4-quadrant chopper circuit, we have to draw axis voltage and current axis. So here we have take voltage axis V0 and the current axis I0. So we can say that output voltage and output current can be worked in every 4 quadrant. So we have take a 4 quadrant like quadrant 1, quadrant 2, quadrant 3, and then quadrant 4. So that is our 4-quadrant chopper circuit. Okay. Now we have to discuss this 4-quadrant circuit into every 4 quadrant. So you can see we have take a big V0 and then I0. So that is our first quadrant. In the first quadrant, voltage and current both are positive. Then that is a second quadrant. Here the voltage and current voltage is negative, but current still is positive. Then third quadrant, voltage and current both are negative. Then in the fourth quadrant, we can say that current negative, but still voltage is in positive. So in this way we can try to explain how 4-quadrant operation chopper circuit can be worked. Now we have to discuss 4-quadrant chopper circuit in details. So we have to take every quadrant in details. So we have to explain the first quadrant chopper circuit, second quadrant chopper circuit, third quadrant chopper circuit, and 4-quadrant chopper circuit. So let us start for the next topic, that is a first quadrant chopper circuit. So in this first quadrant chopper circuit, with a transistor switch is as shown in the figure, you can see. So in the first quadrant, we have to operate from these 4 transistor, we have to operate only 2 transistor. Then in the second quadrant, 1 transistor, 1 diode. So that we have to discuss in this first, second, third, and fourth quadrant. So now you can see in the first quadrant chopper circuit, first we have to take the voltage. Then from this voltage we have to connect with this circuit. Okay, and we have to take first capacitor to maintain a constant DC voltage. Then from this capacitor we have to take first transistor T1, and then here load RA, LA, EMF, and then we have to connect this transistor T2. Okay, so that is our first quadrant chopper circuit. In this first quadrant chopper circuit, if current we have to draw, then its current is flow in this way. Okay, first that is a supply current, and there that is a armature current. So in this first quadrant chopper circuit, you can see only 2 transistor T1 and T2 will be turned on. Okay, and if we see the output voltage across the our DC motor or load, so it will be V0, and polarity across the inductor, that is plus minus, because we know that in inductor property, whenever the current flow through the inductor, then inductor will store some energies. Okay, now that is V0 and I0, and that is our first quadrant. So we can take as a first quadrant because voltage and current both are positive. So we have also switched by some graph also, voltage and current both are positive in the first quadrant. So that is our first quadrant chopper circuit. Now this will be explained by waveform. So if we draw the waveform for the first quadrant chopper circuit, before a waveform we have to discuss to obtain a zero load voltage, either T1 and T2 can be turned off, and assume T1 is off, then the current will decrease in the power switch and inductance. So if we have to obtain a zero load voltage, okay, so either T1 or T2 both, in T1 and T2 one T1 will be off and one other times T2 will be off. So we can say that the circuit is like this. Here we have to assume the T1 will be off. So if T1 will be off, then the power will be returned back to the inductor will change its polarity. Okay, and the diode D4 will be in forward bias condition. Okay, we can say that as current try to decrease in the inductance, it will have to voltage induced across it in the proportion to the rate of flow of current with polarity opposite to the load induced EMF, thus forward biasing the diode D4. So in this figure you can see, we know that the property of inductor, whenever the current will be cut, okay, that times it will change its polarity. So in the back figure you can see, the polarity here, that is a positive and negative, but in this figure you can see the here polarity will be reversed, negative and positive. Okay, so here polarity will be reversed, so that times the whatever the power stored by the inductor, that will be released from this diode D4. Okay, so we can say that the D4 provides the path for armature current continuously during this time, and the operation discussed here, that is a motoring and clockwise direction of forward motoring. Okay, so that is the first pattern chopper circuit, and now we have to discuss for the waveform. Then waveform is like this. We have to take axis. Okay, here in the first you can see that T1 and T2 will be on. Then we have to mode 2, that times T1 will be off and diode D4 and T2 will be on. Then in the next mode you can see the transistor T1 and T2 will be on. Okay, then it will be T2 will be off, that times T1 and D3 will be off, and in next cycle the T1 and T2 will be on. So that is our mode 1, 2, 3 and 4 mode. Now if we have to draw the waveform, then first we have take as a supply voltage, that is a constant DC voltage, we can say that. We have to first take as a supply voltage. So supply voltage is like this. Okay, chopping voltage. Then average output voltage V0, that is here. Now the current, armature current. Okay, whenever our switch will be on, T1 and T2 that times on, that times the current will be in high position. Okay, then it will be off, so it will be decrease. Okay, and then again it will be on, that times increase, and again it will be down, that time decrease, increase. So that is a waveform for the armature current. Now that is the average armature current IA. Then that is a supply current. Okay, if we have to draw the waveform for supply currents, that times when the transistor T1 and T2 will be on, that times the supply will flow the currents, so it will be in high position. Okay, then it will be 0. Okay, when this one transistor will be off, that time supply current will be cut, so that times we can say that that is 0. And again when both transistor on, that times it will be high, then 0, and then high again and 0. Okay, so that is a waveform for supply current, and IS, that is a average supply current for this. Okay, thank you. In this session we have to discuss only first quadrant chopper circuit. Now in the next session we have to discuss the second quadrant, third quadrant and fourth quadrant chopper circuit. Okay, thank you very much.